Good evening. Welcome to Cornerstone Home Inspection Education Center. Tonight, we have a speaker, Chris Morin from Mitsubishi Electric, and he's going to talk about heat pumps and HVAC systems, and I'm going to turn it right over to him.
Geez, Jim, thanks. I appreciate it. That was quick. I'm just going to share my screen here. I do have a presentation for you guys. It's about 45 minutes of content. I want to leave at least 15 minutes, 10 to 15 minutes at the end for Q&A. So keep in mind, because I'm sharing my screen, I'm not going to be able to see you guys or the chat. So I know Jim's keeping an eye on it. If you guys have questions, make sure you put them in. I saw a few that were asked early on. I'll try to work those in. And if I don't, definitely when it makes sense, Jim, interrupt me or Rich or anybody else. So Rich, if you're on, if you want to say hi, because you're obviously the Connecticut contact for us. Just if you want to introduce yourself, and then I'll take over.
Yeah, my name is Rich Layton. I'm the regional sales manager for Connecticut. I work alongside of Chris, and Chris is far better at presenting this information than I am, so I asked him to do it for me. Full disclosure.
Nice. That's great, Rich.
The only thing Chris didn't say, like he said, it's 45 minutes of content, about 15 minutes of Q&A, but unfortunately, we do have a hard stop at 7. We're at another meeting up in Boston that we need to get to for like 7:15. But if you guys have any follow-up, I can, get my email address. Jim has it. I mean, you can get it out to you guys. I live in Connecticut. I live in Middletown, Connecticut. Very accessible. So if I can be of any help, please don't hesitate to reach out. Thanks, guys.
Thank you.
Thanks, Rich.
Go ahead, Chris.
Awesome. Thanks, Jim. So I'm Chris Morin. So I handle business development. I'm a sales manager up here in New England. I work with our sales team closely on the residential side. I also work with our distributors and our contractors in order to help them grow and obviously sell more Mitsubishi and grow their business, right? So my email is right there on the screen, and I'll actually give you a couple other ways to find me as we go through the presentation today. I just want you to understand, I am not just a sales guy. I know Rich probably finds it funny, right? Because Rich has been in sales a long time, like myself. But I started in HVAC when I was 17. My father was in the business. There's a picture of me. I actually got out of HVAC. I tried to get out. I went in the Marine Corps, and they made me a refrigeration mechanic. So I did 2 tours in Iraq. This was my second trip. I was there for the invasion of Fallujah, and that's when I installed my first Mitsubishi system. What I didn't know was 11 years later I'd be working here. And I can say they're not exactly bulletproof, but they work great. And I didn't have all the right tools in the middle of the desert. And they were working awesome when I left there. So obviously, I'm going to be talking about all heat pumps and VRF today. But obviously my specialty is Mitsubishi because that's where I've been working for the last 9 years. I'm also vice president. I'm sorry. I used to be vice president. Now I'm just a board member on the ACA New England. It's an association of about 100 or so residential contractors, mostly in Rhode Island and Massachusetts. We work closely with local governments, try to help with permitting problems, code issues, licensing problems. I'm sure everybody's heard or seen one of those recently. So I'm heavily involved there. And then I also, in the spare time I do have that I don't spend with my young family, I own and run HVAC Pro Blog. So at the end of today, I'll give you a QR code. You can find me on YouTube. There's over 170 videos on there, and you can learn something for free at any time. All right. So today we're going to focus on heat pumps, though. So I'm going to play a video. I'm hoping the audio works great. We tested it before everybody was on, but then I'll get rolling with the details.
In the past, conventional heat pump systems were known for their poor efficiency and performance in cold weather temperatures. But that was then. This is today. Mitsubishi Electric Cooling and Heating's revolutionary heat pump technology and our zoned comfort solutions can give everyone in your home total personalized comfort year-round, even in sub-zero temperatures. Here's how they work. Mitsubishi Electric's ultra-efficient heat pump systems consist of an indoor air handling unit and an outdoor condensing unit, which are connected via 2 refrigerant lines. Together, they work to efficiently transfer the desired cooling or heating energy to your personalized comfort zones. In summer, air conditioning is produced when heat energy from inside your home is absorbed by the system's refrigerant and transferred to the outdoor air. In winter, the refrigerant cycle is reversed, and the system extracts heat from the outdoor air and transfers it inside to heat your home. For those requiring high-performance heating in colder temperatures and climates, our expert engineers have developed hyperheating inverter technology. Our hyperheating outdoor units use an enhanced compressor design to continue extracting heat energy, even when the true outdoor temperature reaches down to negative 13 degrees Fahrenheit. When compared to other fossil fuel burning heating systems, our modern heat pumps provide exceptional heating performance while being a greener, more environmentally friendly option for your home. All of this is possible due to our advanced variable speed inverter compressor technology, which results in our systems using up to 40% less energy than conventional systems. In addition, a single outdoor unit can control up to 8 indoor units for added comfort and efficiency, with multiple styles available for added versatility. Our indoor units also feature true air filtration for your home, resulting in improved air quality with whisper-quiet operation. Perfect for any home, even a baby's nursery. For close to 100 years, Mitsubishi Electric has built a global reputation on quality and reliability. Our innovations continue to make cooling and heating more efficient, comfortable, and healthy. For more information, visit us at MitsubishiComfort.com. Mitsubishi Electric Cooling and Heating. Make comfort personal.
All right. I hope everybody was able to hear that video. I figured some of the basics we could show that. I'm going to get into a lot more detail here regarding how it runs. When we talk about savings, what the actual savings could possibly be. Marketing is one thing. Reality is always another thing, right? So we continue to expand the ability of Mitsubishi heat pumps, as well as the styles and what we're able to do. So what you'll see on the screen here is all of our residential product line. It's a lot of details. What I want to point out is when he talks about the different styles, we make wall mounts, which I'm sure at this point, everybody in Connecticut and Rhode Island and Mass has obviously seen. It's a huge part of utility rebate programs and energy savings and carbon reduction and all that stuff, right? It's been in the market. Mitsubishi's been in the market since 1980. So they're not new, but they've actually just started to hit the mainstream, all right? What a lot of people don't realize is we make a lot more traditional style equipment too, like air handlers. We could actually take a furnace or an air conditioner out and put in a hyperheat performing product to get 100% capacity at as low as 5 degrees and sometimes more negative than that. We have ceiling cassettes, and not just the large 4-way ceiling cassettes. We make a pretty unique one that fits into 16 on center joists. So that way you don't have to reframe a ceiling on a retrofit job in a home. And everything can be serviced from underneath. So we see these sometimes even go into first floor applications where people don't want a wall mount or they can't fit ductwork because they don't have ductwork. They might have a boiler or something in their home, right? But they still want to install air conditioning. And this is a great option to do both, right? We see a lot of our floor mount systems, which is really like a low wall mount, replace where large steam radiators used to be. It's about the similar size regarding the width and the height of an old steam radiator, but it's a lot closer to the wall. It only comes up the wall probably 6 inches at the most. So it becomes really well streamlined, and it actually heats a room more effectively than like a high wall mount where it's taking the warm air from the top of the wall mount and trying to blow it down. And then you end up with some uncomfortable heated spaces where a floor mount takes the cold air in the bottom and it'll actually have 2 vanes to evenly heat the space. So it's more effective in providing heating comfort in the Northeast. And then, of course, we make some other concealed ducted or slimline ducted systems. We make all of this in single zone and multi-zone. And somebody early on asked a question before it started of how I felt about manifold systems. And I assume that you're talking about branch box models. So we make a branch box for our multi-zone systems that starting capacity of 3 tons or larger. And those that may or may not be familiar with tonnage, there's 12,000 BTUs to every ton of air conditioning, right? When we rate our heat pumps, it's actually rated in air conditioning. And typically with our hyperheat performing products, we get more BTUs in heating than the rating in air conditioning. And if we start at a 3-ton model, we make a 3, 3.5, and a 4-ton air conditioning size with a branch box that you can get up to 5 ports or even up, you have multiple branch boxes up to 8 indoor units off of 1 outdoor unit. those systems have really high performance. And I'm going to show you the heating capacity and COP numbers later in the presentation of our largest, what we'd call least performance product, because it's got the biggest compressor, so it uses the most electricity. And I think you'll be pleasantly surprised at how well they do perform. Of course, it all depends on the application and the installation. So there's a lot more opportunity if you're not trained to mess up a branch box installation. So like when you're working with a Mitsubishi contractor, we want to make sure they're what's called a diamond contractor. That means they've been trained. They install many of our systems. There's a long list of pieces that go into their scorecard that we run every year. And there's multiple levels of diamond contractors that you can find on our site. I would start there. Don't worry, you can use anybody, any HVAC contractor can buy Mitsubishi. Unless they've done the training and they've done multiple Mitsubishis, they're probably not a diamond contractor. All right. So that was kind of a brief overview about the style of equipment. We also make many different types of controls, and that's because it depends on the application as to what type of control we want to use. So a lot of our ductless models just get shipped with a remote, right? And the remote will tell the unit up or down, and it maintains the temperature up at the unit. It doesn't sense temperature at the remotes. However, we do make a lot of other controls that sense temperature in the space, like a traditional thermostat. The most popular is actually made by Honeywell. It's what's called the MHK2 on your screen here. It's that rectangle or square model on the top with the blue screen. It's a blue touch screen. It's wireless. It mounts on the wall, and it can be up to 1,200 feet away from the unit and still communicate with it. And it maintains temperature at the thermostat. That's probably the most common application that we see residentially. The next most common would be what's called our wireless interface, or Kumo Cloud. And that's usually what we use to integrate our heat pumps with a third party, like a boiler or furnace, right? So somebody else's system. So that way, like Jim was talking about when we first started, he's got two different systems. He's got the heat pump, and then he also has his boiler. This controls system, if it's a Mitsubishi, will actually automatically switch over from heat pumps to boiler at a certain set point that you set in the system. So it automates that process for you. Of course, we make a lot of other ones. I'm not going to go through all of these. What I want you guys to know is we have a control for every application, even commercial products, right? So Mitsubishi makes all of these pretty much, except for that one that's done by Honeywell for us. All right. We also, for products, make an A-coil. So this is what you would normally see as just a coil on top of a furnace for air conditioning. And we see a huge opportunity in the Northeast market to integrate this with gas or propane furnaces. Unfortunately, it's not rated for the temperature that's required for oil. So we can't do it with oil installations right now. But we make this in 1.5 to 3.5 tons for heat pumps in single zone, and up to 3 tons on a multi-zone. And what's really cool about this product is it actually just wires directly down to your furnace. And you can use that wireless thermostat now to control your air conditioning, your heat pump, and your furnace, because it communicates directly with it. So it's really easy to take advantage of integrated control rebates that are available in your state. So that's the one opportunity side. I would say, and you can see here as a quick picture of power and communications, it's really simple as far as installation, just like any other installation would be. 2 pipes, couple wires, right? I think the biggest opportunity is the unique ability of putting this on a multi-zone with Mitsubishi and addressing comfort problems in a house where normally you would have to do some ridiculous rehab in order to run return ducts, let's say, to the 2nd floor of a Cape-style home, because it's never comfortable when you run air conditioning, or the 1st floor of your colonial, because all your ductwork comes from the attic and it runs through closets, right? So there's a lot of things that have been done over the last 40 years when we talk about retrofit installations in homes. And we have uncomfortable rooms, and what we tend to do is turn the thermostat down in air conditioning to try to feel cooler around the house, when in actuality, it's a ductwork problem or a sizing issue or something like that. And by replacing the existing air coil, the AC coil, with an IntelliHeat, and actually installing one of these indoor units in those comfort zone issues, like a master bedroom that might be over a garage, or a sunroom or a home office, because now it's used for something different, then you're able to actually maintain comfort across all of these rooms now without a huge rehab, right? So on a multi-zone system, we might, let's say, put that AC add-on on the first floor of this cape here to do all that first floor. And then we might run other single zone units off the same outdoor system in order to maintain comfort upstairs, right? The important thing here is if you're using residential systems that are single phase, they all have to be in heating or cooling. It's not heat recovery. So it's not like a VRF system that you would see in a commercial application where you can run one in heating and one in cooling. Fortunately, you can't do that with single phase products, okay? But this gives you the ability of actually zoning with equipment to provide personalized comfort in each room. It's not perfect. You can't just put in an indoor unit in every single room and run one big outdoor unit. That would cause problems. You have to be able to apply the product right. And that starts in the design process, right? And we start to see some of these issues when we look at rebate programs and strategic electrification. So I think you guys probably have seen a big push in Connecticut, Rhode Island, particularly. I saw some Rhode Island guys on there. Massachusetts is another big state when it comes to strategic, it's a mouthful, strategic electrification, and the push to offset or remove fossil fuels from the home, right? And our systems are now becoming larger and better performing in order to do that, with minor upgrades to the home sometimes, like air sealing or weatherization, in order to get it down to where it needs to be. And there's a huge opportunity coming with the Inflation Reduction Act across the entire United States. There's already in place a $2,000 tax credit, I believe. That's 25C tax credit. That's annual. So if you install something in 2023, you already received that tax credit. You can also install another system in 2024 and 2025 and 2026 and continue to get that tax credit every single year. So it's not just a one and done tax credit, all right? And we're seeing a huge push with combining this with a bunch of different rebate programs and fixing issues in the home while actually reducing their carbon footprint of the house. So it's a huge opportunity, particularly for, we were talking earlier about a younger generation that is more focused on comfort and carbon reduction than maybe they were around their electric bill initially, right? They actually value that a little bit more than just energy savings, but we can give them all three actually. So it's kind of a unique situation. Now, all right. And I apologize for talking quick. I am from Massachusetts, so I do talk a little fast. If you guys have questions as we go, make sure you put them in the chat. What I want you guys to know is once a system's installed, it is extremely hard to fix a design problem. And I think you probably know this from everything you've seen out there, right? There is basically three major pieces to a system design. And the third one's really is if you do ducted systems, right? So the first one is do a manual J load calculation. The second one is select the right size piece of equipment without undersizing or oversizing it and understanding how it actually operates in your design conditions in your town, right? And then the last one, of course, is confirming the design and performance. And if you're doing manual D, which is duct design for residential ducted systems, all right? So there is some situations where with any VRF or heat pump residentially, where the system can get over applied if they don't follow the normal design process, because they might just put in the smallest wall mount in every room and try to give what they think is the most comfortable application. But when you add up all those numbers, you end up putting one gigantic unit outside that's too big in order to heat or cool that space. And it short cycles and it causes high electric bills and they're uncomfortable and it makes a bad system worse, okay? So I just want to talk about a few items when it comes to this, and hopefully you're able to talk with, HVAC contractors with a little bit of education if you're not already educated when it comes to the design process, right? So I'll ask you guys rhetorically, which house, can you tell the difference in these three houses and which one has the highest load? And I think you'll quickly realize the only difference in these three houses is probably the color. right? So they all have great curb appeal if you're doing a home inspection, right? But I think what you're going to find is you don't know if the basement's finished. You don't know if the house. You probably could tell if the house has a lot of glass facing south or southwest, right? Or if it's a high performance home and it's extremely weatherized, and those are triple pane windows, right? With really high value spray foam, closed cell spray foam in the attic to encapsulate the attic, and the loads are really, really low. So the same house from the outside might look to, unfortunately, most HVAC contractors like the same size house, but unless they do a site survey and they go through and do a load calculation, they won't know how big the system needs to be, and they tend to oversize them and over apply the products. And that's across the board for every manufacturer. And unfortunately, about 50% of contractors actually size their system correctly. I try to take the positive here. Department of Energy says the opposite. They say over 50% do not size it correctly. All right. That's not good. In fact, in my personal experience over the last 20 years or so, it's actually more than 50%. And you would think the big names and the contractors that do a lot of business, we don't have to worry about them, but sometimes they're the worst offenders. So just because they have a big name in the area doesn't necessarily mean that they're doing the design process correctly. All right. This should get caught in your building permit process. That's part of applying for a building permit to install an HVAC system. Every state calls it something different. It might be a mechanical permit, or in some instances you pull a refrigeration permit, right? Depending on what state you're in. But that's part of that process, is sizing the system, right? Then they need to select the right size system based on the actual heating load, cooling load, broken down into sensible and latent, adding any ventilation load in order to get the right heating and cooling heat pump installed, right? We actually provide software free for our contractors to find out how that system runs based on your design. It calculates all the D rates, and you're able to select the right size piece of equipment. People that don't use that software or do the design correctly, unfortunately, they look at the utility rebate AHRI rated conditions, and they select equipment based on that. And that's not even close to how we operate I know most of you guys are in Connecticut or Rhode Island. They actually rate systems and air conditioning at 95 degrees and 80 degrees inside, which is not even close to what we designed to. And if we actually selected equipment based on that, we would drastically oversize a system based on the design conditions in Connecticut and Rhode Island, okay? And even worse in heating, right? Outdoor design condition of 47 and 17 and 70 degrees inside, which actually they got that one number right out of all the rest of them, right? So we can't select equipment based on rebate information, although that tends to be the number one thing that people look at because they want that utility rebate. And then obviously we teach our contractors to stay within the limitations of the equipment, like line set sizes, making sure they follow the proper guidelines for refrigerant piping. And this changes every decade or so because of the type of refrigerant, right? We're actually starting the transition to A2L refrigerants. And next year at this time, you'll see all of our systems will actually be installed using R454B for residential systems. Right now, obviously, it's 410A. So the good thing is those systems will be more efficient. They have a lot of safeties installed from the factory to make sure it meets all the mechanical code, right? The downside is it's going to be more expensive because all that stuff is built in from the factory. So, and there's slight differences when it comes to refrigerant handling and charging of systems and things like that. So they have to be educated. And then, of course, they need to stay within their capability of airflow. So a great note here is if they have a wall mount system, a lot of our wall mounts will only throw airflow up to 20 feet from that wall mount. If you install, let's say, a wall mount on this wall in this bedroom, this is a hotel room, and this was more than 20 feet that way, you're going to have an uncomfortable space, even when it's at maximum operation. If the system is getting close to your set point and it ramps down, then the airflow ramps down and it's only going to throw, let's say, 10 feet. And that's why you might not feel comfortable on the other side of the room, and people want to sense temperature over there, right? So that gets the system to ramp up. So just a little bit of design pieces here that I want you guys to understand. Unfortunately, doing a home inspection or getting the Mitsubishi service team out after or something because we think the system isn't running right, it most likely, I'd hate to say it, is typically a design issue or a lack of maintenance problem, right? And maintenance, when it comes to, I don't have any slides for maintenance, but I want to touch on it briefly because I saw a couple of questions come in. Maintenance for heat pumps, and I know you guys probably have varying degrees of experience here. Maintenance for heat pumps, because you're running in an air conditioning and heating, you should do it at least once annually. If you're running the wall mount systems, those washable filters need to be looked at probably monthly by homeowners. That's a homeowner action. If they don't keep up on that, what you'll find is most VRF and variable speed heat pumps like ductless systems will actually start to build up dirt and mold on the blower wheel and the vane, right, on that wall mount system. And that is because it's cold and dark and wet, and they're actually getting stuff to stick to that. Now there's a spot for that to grow. So that's the number one thing that you can see if somebody's been maintaining their system or not.
Chris,
Typically, yep.
One question. What's the life cycles of these wall-mounted units?
Yeah, great question. So they've been getting longer. Let me talk about warranty first, so that we understand the life cycle. So warranties out of the box for most manufacturers is typically 5 years on parts and 7 on the compressor. If you have a trained contractor install one of the systems, so let's say a Mitsubishi Diamond contractor installed a Mitsubishi system and they register the system for warranty, they give 12 years on the parts and 12 on the compressor. Typically, you'll see most heat pumps life cycles typically about 15 years or so. If it's installed right, maintained, all that sort of stuff. We've seen Mitsubishis still running after 30 years. So it all depends on everything I've talked to up to this point, right? Did they size it right? Do they operate it correctly? Do they maintain it? If so, then those systems can run an extremely long time. And because of the capability of the compressor and the durability of those, and the fact that they're not turning on and off a lot, that longevity continues to get even longer. So most of the time you'll see 15 to 20 years.
Thank you.
Yeah, no problem. All right. So we talked about airflow range for ductless models. This would be like if you have, you might want to check static pressure in a duct system. I don't think you guys would probably check that, but a contractor would, to see if the ductwork's undersized or oversized, right? So the equivalent for airflow range on a wall mount would be static pressure in a ductwork, right? So if the static pressure is really high, it's probably undersized. You have too much volume of air in that smaller ductwork. It needs to be bigger, or you need to turn the airflow down, okay? So there's a couple things there. Unfortunately, fixing ductwork after the fact, complete nightmare. You want to do this design prior and be able to do this correctly. So if the contractor did a room-by-room load calculation, they can actually size the distribution correctly. And we actually teach our contractors in our applications class about room-by-room load calcs and assigning, let's say, ductless systems that way too. So they want to at least do a zone-by-zone load calc. So if you have one area that's being served by one small ducted system or one large wall mount, we would get the load for that zone in order to size that wall mount or ductwork, right? But not just the size of the ductwork is important. How well it's sealed, how well it's insulated and protected and installed is important as well. So on you guys' end, unsealed ductwork actually can contribute to 1 to 2 tons worth of additional heat gain or heat loss, right, in the calculation. So a lot of times people will have to oversize systems because they're putting them into existing poor ductwork. They're not fixing it, right? If they were to seal the ductwork, that's the number one thing, seal it, then we don't, in the return, bring in a lot of attic air or a lot of, let's say you have ductwork in a basement, you might bring in a lot of moist air in the basement that would raise the latent capacity needs of the system and it won't air condition well, right? If we seal it up, it makes the system run much easier, particularly a variable speed system. then we would insulate, right? And we want now to meet the IECC codes, it would be R8 on all ductwork within the building envelope, right? All right. Last one on here is diffuser selection. And this is just to point out, you want decent coverage of the room. So as an example, we wouldn't put a 4-way diffuser in a corner. It makes no sense, right? But it's amazing what we see out. A lot of times, the problems we find is people adding air conditioners or heat pumps to an existing furnace or replacing it, and they don't look at the registers, let's say on the floor or the ceiling, and those were selected based on the furnace, not based on the airflow for the heat pump or air conditioner. And that can cause comfort problems and noise issues when you're running more volume of air through that duct system. Becomes almost like a whistle sometimes. And if it's running really slow because it's too big, that cold air will actually create this Venturi effect, and it'll continue to make that metal register cold. It'll actually start to sweat, and you'll start to see mold air, grow around those registers. Happens very often in attic-based systems that may not operate in the wintertime, right? When you talk about air conditioners and possibly humidifying spaces like bedrooms and stuff, and that humidity hits that cold register. The same thing can happen when you turn a variable speed system down and it's not running the right speed for that register selection. And these are all things that should be fixed in the design process. That's really hard to fix afterwards, right? All right. So let's, I'm going to talk about comfort, because obviously there is a bit of a stigma with heat pumps. Hopefully when you saw the video early on, you understand that Mitsubishi now over the last 15 to 20 years has done a great job on getting cold climate performing heat pumps into the Northeast with extreme success. So we have systems where it's the sole source of heat in Presque Isle, Maine, and never had an issue, and it was -20, -30 degrees up there last year because it was sized right. It doesn't matter if the BTU is coming from a heat pump or from a boiler or from a wood stove. You're getting the same amount of BTUs, and you just need enough, right? So luckily, we don't need as much as we need. We don't need as much in Connecticut as we do in Presque Isle, Maine, right? So in air conditioning, the highest temperature that we design to in Connecticut, and this is right out of ACA Manual J, is 88 degrees. That's the 99% design condition, meaning when you add up all the hours that it's warmer than 88 degrees, it ends up being 3.65 days, 1% of the year, all right? So if we size to 88 and it's warmer than that, the system's going to run all the time to try to maintain comfort, all right? It may not be 75, it might be 76, but since it's running all the time, it's going to remove more moisture and it should feel comfortable, all right? The bigger problem is when we size to a really cold temperature. The coldest temperature we design in Connecticut too is 2 degrees, and that's in Waterbury, all right? So that represents 1% of the year it's colder than that. So when you add up all the hours, and it does get colder than 2 in Waterbury, in most of Connecticut, right? At some point in the year. But all the hours you add up, it ends up being 3.5 days. So we have to stop the oversizing somewhere. And those are the agreed upon temperatures in the code, the IRC and the IECC, all right? So knowing that, let me talk about performance of heat pumps. So traditional heat pumps, when we talk about a balance point of where we can provide comfort, and I apologize for the charts and graphs here. I know Jim's recording this. Hopefully you can go back and watch it again if you need it, the detail. The heat loss of a house is lineal, right? So let's say as an example, we have an 80,000 BTU heat loss for this home. We need 0 at 65 degrees, right? The opposite, going from right to left, is performance of a traditional heat pump. Okay, if we design to 5 degrees, because that's close to what you design to most Connecticut homes, somewhere between 2 and 7, right? You can see that we would cross this design heating load in a traditional heat pump that's 5 tons, somewhere around 36 degrees. And that means it doesn't matter what fuel you have, you won't be comfortable with a traditional heat pump without having supplemental heat below 36 degrees. And this was always the issue until we started coming up with cold climate heat pumps somewhere around 20 years ago, okay? So when we sized that supplemental heat, it was for the difference between, at my design condition of 5 degrees, of what my heat pump can put out from what I need, right? So in this case, I needed over 60,000 BTUs, and it was almost impossible. The electric meter would be spinning if I was running 60,000 BTUs of toasters in that duct system, all right? So what's cool about hyperheat products or cold climate heat pumps is that curve is flat all the way to 5 degrees. So as an example, I have a 4-ton heat pump that gives me 54,000 BTUs in heating all the way down to 5. So it doesn't mean I can do 100% capacity because I need 80,000 BTUs in this fictional home. But you can see now I can run that heat pump for comfort purposes all the way down below 25 degrees before I have to turn on either another source or a much smaller amount of supplemental heat. In this case, just over 20,000 BTUs. So less than a third of what I would have needed prior, okay? So we've seen this huge advancement in performance and capabilities and application of heat pumps to a point where we just about hit mainstream, okay? And if we're sizing emergency heat is sized for 100% of this. Emergency heat is, I'm going to turn my heat pump off and flip over to something else, all right? And if you're sizing dual fuel systems, it's the same thing. I would have that size, the largest heat pump in this example, and then I would size my furnace for the full 80,000 BTUs. And then I would consider what is the right temperature to switch over based on cost, not comfort, because I can handle it all the way down to 20 something, but it might be cheaper to run gas when it's warmer, right? And I'll show you that in a second. Hopefully everybody understands the simple AFUE. AFUE is annual fuel utilization, right? And that's just a percentage of what's being burned turns into heat versus what's going out the chimney or the flue pipe, right? So a 96% furnace is always 96%, no matter if it's 0 degrees out or it's 50 degrees out. The bad thing, I shouldn't say the bad, the one negative thing is the coefficient of performance, which is the equivalent for heat pumps, gets worse as it gets colder out. I can, with a high efficient hyperheat product, I can get the capacity all the way to 5. It just uses more electricity to give me that capacity, okay? So when it gets colder out, it becomes more expensive to operate the heat pump, all right, than it would be when it's warmer out. But it still may be less expensive than other fuel sources. So what Mitsubishi and most manufacturers provide is some sort of energy cost estimator to show you if I replace that furnace, that oil burner, or that propane boiler, or whatever you have with a Mitsubishi cold climate heat pump, you can expect to pay X amount annually to run this system versus that system. It's a simple Excel document. This is available. Rich can probably follow up if you're interested, all right? And you can compare wood pellets or wood, or if you know the cost of whatever, you can plug it in there, okay? Including replacing window ACs. So if you're going to replace window ACs, you might get some efficiency gain in the summertime too, all right? This actually has a pretty cool little tab. It'll tell you, based on your load that you put in there, how much you can displace with the system that you're specifying before you would have to switch over for comfort, which is the chart I was just showing you, okay? So let me give you an example here. I happen to live in Massachusetts, and I'm really close to working with utility companies up here. So I know the Mass and Rhode Island energy prices. I have to imagine Connecticut's not that far off. It's probably close. It might be a little lower on oil, a little less on electric. But it's going to be somewhere in this range. This was back in January. It fluctuates all the time. So what I'm going to show you is based on these energy prices. And knowing the cost per therm, the gallon, the kWh, it's simple math to figure out which COP, based on your fuel type, I should switch over at what temperature, because it's less expensive to run natural gas or oil or whatever it is, okay? So I did all the math for you. If you're interested on how to do this longhand, you can go to hvacproblog.com, or if you just Google search break even COP, I'm typically the first one to show up, all right? There's a video and there's also a blog on how to do it. It's pretty easy. So based on these fuel prices and the least performing product, meaning it uses the most energy because it's the largest condenser we make, that's the 4-ton model number in the top right of your screen. That gives me 54,000 BTUs, actually all the way down to 2 degrees, right? This math will break down based on the cost of natural gas, the cost of oil, and the cost of propane, what the break-even COP is. And you'll notice all the way the column, all the way to the right, as it gets colder outside, the COP goes down. It becomes less efficient. When it's 55 degrees out, our system is 484% efficient, a COP of 4.84. You'll notice the worst case, the rating we have all the way down the bottom, 2.11, okay? So based on natural gas, it's actually right now for these costs and this particular condenser, less expensive to run natural gas about 47 degrees or less. Above 47 degrees, it's less expensive to run your heat pump, this heat pump, okay? And when you have a lot of smaller systems, they're a lot more efficient here when you talk about COPs. Oil, you'll notice it's all the way down to about 4 degrees, and propane's not even on the chart. As long as you're comfortable, you should run a heat pump instead of propane because it's way more cost effective, okay? As long as you're comfortable, that's the key. If you don't have enough BTUs, you're gonna have to turn the propane on, right? All right. So remember, this is for this condenser at these fuel prices for that particular fictional home. It is always different. So we can't say like, hey, what temperature should I switch over to my oil? It depends on the efficiency of that, the cost of your oil, which changes every week, the cost of your electricity, which seems to change every week, but it is regulated. It's probably at least quarterly, unfortunately. So it's too many variables, and we tend to give people ranges unless there's a drastic change in the fuel cost. So usually natural gas somewhere around 45, somewhere in that range, 45 or less. It's less expensive to run a high efficient natural gas furnace. This was a 96% furnace. Oil, I'd say somewhere around 5 or less. And what you'll find a lot of times is this is worst case scenario. Our system tends to perform better than what we publish. We're a very conservative company. So what I want to point out here is based on design conditions, if it's less expensive, if I kick back one, to run oil all the way down you run heat pump versus oil all the way down to about 3 degrees, that makes up more than 99% of all of the run hours in Hartford, Connecticut. So that means it would be less expensive in Hartford, Connecticut to run that particular heat pump, which is our least performing product, compared to oil based on those prices. And if you're in New Haven, it's even better, right? So depending on run hours, you'll see here, we only have 30 hours that it's below 10 degrees in New Haven. So unfortunately, there might be 2 hours where it's negative 15 once a year. But there's only 30 hours that's the case. As long as you don't shut that system off, it's going to maintain temperature. The problem is large setbacks like we used to have with single stage equipment that it has a hard time recovering. And typically it can be as much as 1 hour per degree in either heating or cooling if you have a really large setback. All right. All right. So if you have your phone available, there is my QR code I offered it right at the beginning. If you want to learn something for free, HVAC design or system diagnosis or efficiency or quality installation related, there's 170 different videos or so. There might be more than that now on there over the last few years. Please check it out. I am going to open it up for questions. I think I hit some of them, but I'm sure there's a lot more.
So we have a couple of questions. How to keep the condensate line from dripping in home or a business wall? Even if the filter is cleaned weekly, they still tend to clog and drip.
Okay, so if the reason is that it's clogging and it's overflowing, so if that is for a ducted system, then chances are you need to have an overflow switch installed in the drain in order to stop that from happening. That's actually a code requirement. All right. Second thing, if it's actually condensation on the drain, it may just need to be insulated because it's in an unconditioned space and you're running, let's say, 50-degree water through that. The temperature might get below the dew point of the air if it's in an attic or something. or if that wall is adjacent to unconditioned space, right? So the temperature of that wall might be much higher. If it's literally just running down and it's clogging, if it's continuing to clog, then they need to have a deep cleaning of the system. So meaning starting right at the filter. So right from the filter on, they need to pull the blower wheel, clean all of the blower wheel, right? They need to clean the AC coil or the heat pump evaporator, and then clean the evaporator pan all the way out and then clear the drain. That's the way to stop that from continuing to happen even after you keep clearing drains. So unfortunately, if you just replace the filter and they don't clean all the stuff that happened to get by the filter, you just end up with the same issue over and over and over again. In fact, it might happen more often because now we're getting more volume of air across that because we replaced that dirty filter. So hopefully that makes sense.
The second question is basically in the winter, are there freeze-ups when light snow? How to avoid?
Great question. Okay, so there's a couple different things here. As long as you operate the system continuously, you don't turn it off, the airflow movement across a heat pump will keep that clear in front of it. As long as you don't like plow it in or something, right? If you do turn it off and that snow builds up, you have to clear that before you can turn it back on. All right. So an extreme event, it's possible, but as long as you're actually running the system, it tends to stay clear. Now, the ice up situations, there's two reasons for that to happen. One, it's undercharged. There might be a refrigerant leak, and that's why it's freezing up more often, and it can't actually clear all that ice. Or two, it's really humid conditions in the winter. So that is when we start to see a lot of defrost cycles. And that happens a lot more often closer to the water or closer to lakes. And we have to stop any sort of drip edges or stuff that comes off of roofs as well. That can create a large ice box. So there's actually caps that are sold that go on the top of these outdoor units that have a rain drip like gutter on the front of it to stop it from building up in the front. A lot of times that drip or that moisture will start to build up on the top of the heat pump. And when it drips down the front, it blocks that fan from being able to start the defrost cycle. So we got to keep those clear. Protecting the top of it with one of those caps is one way. Not shutting the system off is probably the best way during extreme events. So
as inspectors, when we show up to a house and we see these units, a couple of things right off the top of my mind. Is there a minimum distance off the ground that Mitsubishi requires?
So we keep it nice and vague for everybody, right? We say above the local snow level. So that could be 4 inches, that could be 12 inches, right? So what I highly recommend is you use either a stand or a wall bracket. We recommend stands that are not attached to a wood frame building because unfortunately you will get a resonance noise through that wood framing, right? It's almost like a bass drum noise. So a lot of times people will actually put them on a stand that is probably 12 inches off the ground. I would say at least 6. What you don't want is someone just to put like, pressure treated wood underneath or something. That's the worst. So there's a lot of different manufacturers of stainless steel stands. Highly recommend they use one of those. And as far as inspectors go, on you guys' end, make sure it's off the ground because there's drain holes in the bottom of that condenser that follow along the coil. And those drain holes need to be cleared so that way that when it runs those defrost cycles, the water can drain down and out. So if you're doing an inspection, looking in where the fan is to make sure there's no debris in the bottom of that condenser is important. And that has the ability of actually draining the water out of the bottom. That's huge.
Now, I know a lot of inspectors like to, when we go and we see something and we visually look at it, a lot of times we can tell if it's very old or very new, but some clients demand, they want to know exactly how old it is. Is that age printed on the plate or is it in the serial number?
So it is all over the place because they're manufactured at different plants around the world. So each plant uses a different strategy for serial numbers. So it's not simple like let's say a unitary manufacturer in the United States that'll actually put it in their serial number, very obvious. Ours, we put the month, the year, depends on the model of the condenser because there's only so many digits, right? So if it's this model, then that's maybe 2000 to 2009. This model is 2010 to 2019. So you'd have to know a combination of the model and the serial number and which factory it was built in to know what that is. So what I highly recommend, if you want to try with Mitsubishi, the best thing you can do is if you go to the website, it's registermehvac.com, and you can look up to see if a model and serial number is in warranty, and that will tell you the installation date. So
what was that again?
It's register, the word register, ME for Mitsubishi Electric, HVAC.com.
There's not a number like thermal pry we have to call. You can't call a number. There's no number.
You can if you want. So if you want to call 1-800-433-4822. That's our customer care line. They take everything from homeowners to distributors to contractors. Pretty much, I think it's 7 or 8 a.m. until 5 p.m. Oh, no, I'm sorry. Yeah. It goes to 7 p.m. because of the West Coast.
And guys, I'll post this on the website tomorrow by the end of the day. So that information will be there.
Awesome.
Any questions that we have from anybody?
You talked about that mold. When the guys are servicing them, can they actually spray, clean all the filters and get rid of that? Because we see that a lot.
Yeah, that cleaning, unfortunately, is very intense. So most contractors, they use what's called a bib kit. So they'll take the casing on the outside off and clean that outside. And then they'll put this bib kit on in order to spray with the system off, to spray all that mold out and down into this like bucket, right? What a lot of people don't realize is the drain in the back of these wall mount systems, actually the back plate has another drain in the back. So if they don't clean the entire system and they just clean let's say the blower wheel, they may not get all of that mold and stuff that's in the back drain. So doing a complete cleaning when you see mold on the wheel, because if you see it here, you know it's previous to it. So you have to do a deep clean in that instance. Now, a little side note, in the last 3 years, Mitsubishi actually developed something called dual barrier coating. So all of our wall mounts now have this coating on anything the air touches, where mold and mildew and stuff cannot actually attach to it. So those tend to stay crystal clear for years. So we've done simulated tests for like 30 years of runtime, and it looks new. It's pretty cool.
The other thing that I've been seeing a little bit of advertisement on are homeowner actually installing pre-charged systems. You familiar with this?
I'm very familiar with this.
Okay.
So
yeah, I don't like the homeowner doing anything.
we don't. That's not. So Mitsubishi does not have a system that can happen, right? So you're talking about like Mr. Cool, Friedrich, and a few other manufacturers that sell directly to homeowners that come with pre-charged line sets to try to install it. Unfortunately, there's a lot of issues if homeowners do this. Number one is they don't tend to make the line set the right length. So they're pre-installing it. And if they install that line set vertically, it creates oil traps and will kill the compressor within like a year or two. All of that excess line set would have to be installed horizontally for it not to create an oil trap. And then just what we've heard is like, they don't have like a place to get parts or service support or anything like that. They're literally buying a box, and when the box isn't working anymore, like any other appliance, they go buy another box. So if it's professionally installed with a warranty, we're talking 15, 20 years. This is like a really simple solution, low cost, very low efficiency in order to do like, let's say a man cave or like a garage or something like that people are doing.
On the refrigerants, you said that you're going to be changing. What happens to systems in the last 5 or 7 years if they lose charge?
Yeah, so you'd still be able to purchase 410A. Unfortunately, they're not backwards compatibles, so you couldn't like use a new system with an old condenser or something like that. But you'll still be able to purchase refrigerant for service purposes. What is good though is the line set sizes for Mitsubishi are pretty much across the board the same size. And because they use the same oil, you can use those line sets with a new system. So if you do end up replacing a unit earlier than you wanted to, because of warranty or whatever it is, then you don't have to replace all the line sets and the electrical and all that sort of stuff residentially. They all match up with the new systems.
What's a cost on average cost? I know it varies throughout the country, but
it's all over the place. Yeah, I've seen, to give you a range, I don't know, like a single zone system in Massachusetts is anywhere from $6,000 to $9,000 installed on a large single zone unit.
Yeah,
right. Yeah. And then, multiple zones, it tends to be very similar. So it might be $6,000 a zone or something like that. That's probably on the lower end. If you're working in Boston, it's probably more expensive.
Now the last question, because we're at 6:55, I want to let you go a little early. And I thank you for your time. Those super efficient ones where it's like negative 13 degrees. Yep. Those are crazy expensive, aren't they? They're
not that. So what's interesting is, yes, they're more expensive than a non-hyperheat product for sure. It could be as much as twice as much. But like the single zone ones I was talking about are the $6,000 to $9,000 installed, right? The multi-zone systems that are hyperheat, those are the ones that tend to qualify for really high rebates and tax incentives. So when you take into account the rebates and tax incentives, a lot of times they cost less than installing something that doesn't qualify for a rebate and tax incentives. So good contractors going to know this going in, and they're going to explain like, sure, I can put the base model in, but it's going to cost you more compared to this with all these incentives.
Well, Chris, thank you very much for your time. And this was very, very informative. It was
I'm glad. I was worried, I didn't want to get too deep in some things. I want to make sure I covered enough for everybody. It seems like hopefully, based on the questions, people were happy. If you have follow-up at the beginning, I gave my email. Feel free. Obviously, Rich is your local guy. I'm sure he's more than happy to step in when needed, Rich.
Yeah, Jim, if you could forward me the list of everyone's email address when you get a chance, that would be great. Their contact info.
Yes, I will.
And then the other thing, Chris, I wanted to add, if I can, in talking about cleaning the systems, is we didn't touch on the fact that we don't want any type of evaporator cleaners on there, that we only recommend using a simple green water. None of the evaporator cleaners that are sold in different supply houses, Mitsubishi does not recommend using any of that on any of them.
No bleach, none of that.
Right. None of that. It'll pull that proprietary
coating off.
Coating right off the system.
Yep.
So it would be like the equivalent of installing it in a nail salon. It'll just rip that stuff right off. So, Rich, I don't know if you want, we can offer, if you guys want to learn more about A2L refrigerants or any Mitsubishi stuff, we have a free learning center that Rich can set you up on, and you can go on there, and there's hundreds of webinars and online learnings. You can learn anything from service to specific products or more general stuff, even our commercial line.
It's all self-paced. It's all self-paced. There's, courses, videos, YouTube. There is, on the LMS system, there is so much information that may answer some questions that didn't come up during this conversation today. So if you want that, I'd be more than happy to let me know, and I can get everybody set up individually with an LMS account.
Great. I will work on the communication and get everything posted online. And if anybody's interested, they can reach out to you.
That's perfect. Thank you for the time. Thank you for the opportunity. And Chris, obviously, as always, thank you for taking the lead on this thing.
Anytime, Rich.
Great job, guys.
Great job.
Thank you, guys. Have a great night.